All right. So, hello everyone. Um, Welcome back. So today we have another late night stream where we're probably going to be doing Psych Soc. I'm thinking, and we're probably going to finish biochemistry from yesterday. I changed some of the settings, so hopefully that affects how the cards are shown because yesterday there were some it was kind of random. I don't really like that. I'd rather the cards just show up in order that actually makes sense. Like if they're gonna explain something, at least they explain it to me before I get there. So hopefully we can see that reflected in the cards today. uh i I predict, like, based on my pan cow, as you guys see, I had like 900. Like I have 900 due cards in Panko. That's like maybe like half the deck. So I'm hoping that that can help me get through today a lot faster than yesterday, since we did end kind of late. But I'll probably do these 19 cards and then do the other 50 on top of it. Because I think we had some easy cards left. But I guess it all really depends on how the review cards go. I hopefully that doesn't take too long. But I don't know. I guess we'll see. We'll see what I can do. All right, so let us get started. About chemistry. Okay, I think it's set so the reviews are first. Okay. All right, asparagine structure, character, to that abbreviation. Okay, so asparagine, it was something like boom, boom. I'll get it after this. We have this is gonna be the NH2, just to make sure that I remember the structure. Asparagine is this one has is this I think it's like this. And then if I'm not mistaken, I wanna say it's like this. I know the H2 is supposed to go on the other side, but we're just gonna put that there. Then this is gonna be this is polar ASN, and it's gonna be N for this one. Let's go. All right. Uh, I wasn't 100% sure. I'll give myself hard. What are lysine structure, character? Okay, so lysine. I remember that we had 1K, 2Ks, and then boom. And then this is basic, so it's gonna be NH. Probably three, honestly. If it's gaining a plus, it probably turns into NH3. It's gonna say H2 because it shows neutral, but okay, low key, I forgot to check. I forgot to check for the three letter or the one letter abbreviation. So let's check. I'm gonna check the charge, the charge molecule. Lysine charge structure. I'm sure it is. I just want to be 100%. All right, cool. I was right. We can do that again. What is a peptide bond? This is gonna be peptide bond. That's just a bond between the amino group and the carboxylic acid that's gonna hold peptides together. I say peptides, but it's because the amino acids form the peptides. Like all of them together are gonna form the peptides. I don't know. I'm gonna say I'm gonna say I'm gonna say hard. What are serine structure, character, three letter abbreviation? What up? Is it possible for me to? kind of want. I don't think. I don't know if that's like tweaking the the camera when I was doing that. But what's serine structure? Serine should just be boom boom, and that's a OH. Yeah. What are histidine structure? Histidine. Okay, this one is like this is this might be a little rough. Hopefully this is gonna be correct. I think it's like this. This is gonna be an N, and this one is gonna be an N. Um, Obviously this is gonna be the place where the plus is absorbed. I think. It's HIS and H. It's basic. Okay. I didn't put the H. I didn't put the H on this one, but like I don't know. Like it's like I'm not gonna do that. I'm just like I'm just shorthanding it. Um Histidine. I just want to make sure. I like knowing the charged forms as well. Uh why can't it be so like more accessible to find what the charged forms look like? Why is it so difficult? Yeah, okay. I was right. All right, yeah. That's pretty much the answer. So I got it right. Methionine, I'm pretty sure that's like a one, two, three, four, and then this is just an S right there. Yep. What are tryptophan structure? Okay. Tryptophan. Okay, this one is annoying. I remember that. Ooh, that was a that pentagon was kind of crispy. Uh okay. That was not kind of crispy to be honest. Um all right. Where is there's more to this, but I low key don't remember. There might be an N right there, but I don't know if there's another bond. I'm gonna say there's not. And then I'm gonna say I know this is W. It's TRP. Tryptophan is non-polar. I think. Yeah, it is non-polar. Okay. Well, I put it in the wrong place again. I keep doing this, bro. All right, arginine. Okay, arginine is what is it? One, two, three. Low-key, I remember. I remember it being down. Like it's on a down that it does it. It might be one, two, three, four. Arginine. No. I. Okay, I'm just gonna go with it, bro. If if I mess up, I mess up. Uh, and the charge is gonna come up here. This isn't positively charged right now, but it's gonna go up there with the hydrogens. Arginine is gonna be ARG, and it's gonna be R. It's basic. It's like very basic. Um. Oh, nice. I was right. Perfect. If pH is lower than the pKa of a group, then the group is gonna be. If pH is lower, it's gonna be protonated. What is a subunit? It's uh, one of the functional peptide chains in the quaternary structure of, I don't know, like one peptide as a whole. Okay. One of the functional tertiary peptides. I don't really like my definition, so I'm gonna give myself that again. It's a residue is just an amino acid. What are leucines? I can't. I don't want. I don't really want to give myself that. I'm gonna be honest with you. Leucine is gonna be like a boom, 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 or or watch it be boom, boom, boom. Oh my god, wrong. What is DNA sequencing? Okay, so DNA sequencing is they're gonna take they're gonna have one sample. It's gonna be split into four different tubes. PCR or gene cloning is gonna be run on it using different ddNTPs, and that's gonna be a portion of the primers, or not the primers, but like that's gonna be a portion of the nucleotides that are going to be inside of the PCR. Um, so when the ddNTPs bind, it prevents elongation from the three prime end, and that means that it's going to stop in different places, and using that you're going to be able to organize it by shortest to longest using gel electrophoresis. What is a lipoprotein? It is a it's a protein with a lipid based prosthetic group. Damn, I had to pull that from the depths. What is a beta pleated sheet? Um, it's like when the amino acids form rows, like they lie next to one another, forming rows. Hold up. Yeah, I don't know why it's saying like a structure in which peptide chains lie alongside one another, because it's like the same peptide chain. So why is it saying that? Hold up. I'm gonna I need to look this up. Um I know I look a lot of stuff up, but I said I wanted to document everything, so isn't this technically wrong since it's not multiple peptide chains, but actually one peptide chain that is forming rows with itself? Like, it's like different portions of the peptide chain. So I don't know. I'm gonna give myself again, but With the exception of glycine, what are common methods to denature proteins? So heat can destabilize. Uh, heat's gonna destabilize hydrogen bonds and hydrogen bonds. Oh, salt bridges, hydrogen bonds and salt bridges. The solutes are going to dissolve. Uh, the solutes are gonna dissolve. Oh, for solutes like beta mercaptoethanol and DTT are going to disrupt disulfide bonds, and detergents are going to disrupt non-covalent bonds. What is the isoelectric point? That's the point when the like amino acid is neutral overall. Hmm. I didn't say pH. Uh, okay. Unfortunately, I have to give myself that again. I'm pretty sure that's literally just a methyl group. The character is going to be nonpolar, ala, A. Yep. Describe the strength of the peptide bond and why? Because of resonance structure, it's resonance stabilized. What are the proteinogenic amino acids? Those are the amino acids that are encoded by the human genetic code. Formation is oxidation reaction. So what is cysteine structure? Is it just SH? Yep. What is a solvation layer? What does it result from? So solvation layer is it results from electrostatic interactions. I remember that. And the solvation layer is a layer formed by solvent molecules around a molecule. Realistically, I wanted to say like a solute, but I guess whatever. Um, yeah, that's what I said. I didn't say nearby, but that's like implied. Threonine. Okay, so I'm pretty sure it's literally just this. Like, or is that valine? That Loki might be valine. That looks a lot more like valine. Well, okay, it's not valine because this isn't OH, right? Please tell me that's right. It's THR polar, and I'm gonna say T. Nice. What is isoleucine structure? Uh, it's gonna be like what is tyrosine structure? Boom, boom. I'm just gonna draw a circle. And then it's gonna be the OH at the bottom. And it's gonna be TYR. The one letter is Y. It's obviously polar. The pH is higher than pKa. It's gonna be deprotonated. What are lysine structure? Okay, I don't really know why I'm doing this though. And then I did it's because of the K, the stupid K, and this is gonna be NH3 when charged. Peptide bond formation occurs via dehydration reaction. Proline. Okay, so we actually need to draw the whole thing out for this. not the whole thing, I guess, but uh, I don't really care about that part. We have the N here. Boom, boom, boom. I'm okay just gonna extend that down. All right. I don't think there's any double bonds anywhere. I think that's literally it. And this is gonna be obviously an H. Yep. Nice. Why is the pushing of nonpolar amino acids to the core spontaneous? Because they don't like water. It decreases entropy when you put it, if you try putting it into like the cytosol. Which amino acids are most commonly targeted? Serine, threonine, and tyrosine. Amino acids with basic side chains have, it follows pH, so it's going to be a high. What is secondary structure and what is its characteristic bond? Low-key, I'm going to change that to this. What is secondary structure? That is the protein structure that is formed by hydrogen bond interactions between the backbone, between the amide and the carboxyl group. All right, cool. What roles can the formation of quaternary structure serve? Um, of quaternary structure. Okay, this one had four things. So it can, I know it can reduce the amount of DNA like necessary in order to create a protein complex. It can help stabilize a protein. Um, it can induce cooperativity, and it can help shuttle an intermediate to the next step. Bring catalytic sites together, something like that. Damn. What is Witter ion? It is. What? I feel like I did this. Bitter ion is it's like an amino acid that's overall net charge is 0. What is tertiary structure and what is its characteristic bond? Tertiary structure is formed through, I low-key do want to say disulfide bonds, I'm not gonna lie. So I'm gonna say it's formed using disulfide bonds, uh, using it's the 3D structure, and it's also through hydrogen bonds between the side chains. I know that, but what is the other one? Salt bridges between positively charged and negatively charged side chains. Okay. Tryptophan structure. Okay, let's try this again. Boom, 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 boom. Okay, so we have an N right here, an N, line right there, a line right there. This is TRP and this is W. I did this right, right? How do I keep getting this wrong? Am I doing something? I think I'm drawing this. I'm just drawing it wrong completely. Let's see. So, bone, 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 bone. Okay, low key, I'm just gonna draw. I'm gonna draw the pentagon first. And then I think it's low key. And low key doesn't even go there, bruh. I think it goes like here, right? It's like a side by side type of thing. Yeah, because these are like the points. I've been drawing it wrong the whole time. And then this would be able to go there. This can go here. Yeah, that makes sense. Okay. Glutamic acid, that's like one, two, three, four. OH, double bond to O. Acidic or negative, GLU, it's E. Oligopeptide is a peptide chain made up of up to 20 amino acid residues. Oh my bro. These are like easy questions, which is what's annoying me. What are leucine structure? All right. So leucine, I low key, I just leucine is just like it's like valine, but with one more, bond. I got that right. I don't know why I clicked again. What is denaturation? When it loses, it's when like a protein loses its 3D shape, its tertiary structure. What is a subunit? A subunit is a part of a. It's one of the functional tertiary peptides forming a part of an overall quaternary peptide. One of the functional tertiary peptides comprising the overall quaternary peptide. Okay. Residues, it's one of the individual amino acids in a protein. Describe the special role played by proline. Where is it found? So it causes like kinks. It's found in the beginning of helices and the turns of sheets. That's a result of its like unique structure. Glutamine, one, two, three, four. And then this is gonna be what is it called? What is that group called? Oh, I don't know why I said amide group. It wasn't even an amide group earlier. My fault. Okay. So yeah, this is an amide though. This is gonna be the NH2. And then there's gonna be GLN and N. Oh my, it was Q. I had it. They're all L amino acids, and cysteine is the only one in R. Phenylalanine, I'm not even. It's this and then the ring. What is cysteine? I didn't even look at the answer to the last card. The one letter was definitely F, but I knew that. Cysteine is a protein with a disulfide bond. It's like what you call the disulfide bond between two proteins. C-terminus, that's the free carboxyl group at the end of an amino acid chain. Valine is boom, boom, boom. It's all metals. During the formation of tertiary structure. Oh, I forgot about the lo-fi. Hold up. Um, okay. So, during the formation of tertiary structure, hydrophobic amino acids are pushed into the core. What will the titration curve of an amino acid look like? It's gonna look like okay. This is gonna be there's gonna be PI. This is gonna be PKA1. There's gonna be PKA2, and this one is gonna be for the amino. This is gonna be the carboxylic acid. It's an OH equivalence. I didn't look at that part, but it's an OH equivalence. I'm just gonna like a combination of two monoprotic titration curves. Do I want to remember that? It's when peptide chains lie next to one another, forming rows, and they form that structure utilizing the hydrogen bonds between its backbone. What is the isomer? It's the pH at which the amino acid is neutral. In what direction are peptides drawn? Uh, I think it's like, I think it's, I feel like it has to be something like this, like ON. Left to right from N terminus to C terminus. Oh, I should have known that. What are aspartic acid structure, character, 3-letter abbreviation, and 1-letter abbreviation? Aspartic acid. 1, 2, 3. And then that's gonna right here is gonna be the 2 bonds for the carboxylic acid. What is a conjugated protein? I don't know. protein that derives part of its function from the presence of prosthetic groups. Prosthetic group, the non-protein part of a protein required for the protein to be functional. Oh. A conjugated protein. What is a glycoprotein? Um, Carbohydrate-based prosthetic group. How does one calculate isoelectric point? Oh, sorry. So isoelectric point, I'm pretty sure it's just like the average um between, so it would either be you add up if it's if it doesn't have like a side chain, um then you would do if it doesn't have a side chain or like a pKa3, then it's gonna be the average between pKa1 and pKa2. If it does have pKa3, it just depends which way it's leaning. So I think it's if you have one of the basic ones, you would average that out with pKa2. If you have one of the acidic ones, then you would balance that out with the pKa1. Yeah, that's pretty much like exactly what I said. That's like exactly what I was describing. What is a prosthetic group? Uh, it's a it's a molecule that's attached. It's not part of the protein itself. It's attached to the protein that allows it to function. Hold up, let me edit this. Examples. All right. I don't know what. I clicked the button. Okay. What is a peptide? I feel like this is the type of question that I was saying. Like, why is this so like? Why is it the case? Why is this question coming up now? Is my question. What is a peptide? It's a chain of amino acids. Yo, how did I get that? That was actually pretty good. Okay. What roles can the formation of quaternary structure serve? What roles can the formation of quaternary structure serve? Okay, so we're doing this again. Uh, um, what roles can the formation of quaternary structure serve? Okay, sorry, I got distracted. What roles can the formation of quaternary structure serve? It's going to be to stabilize a protein, to reduce the amount of DNA necessary for like reduce the amount of for a protein complex, to bring together catalytic sites in order to shuttle an intermediate from one catalytic site to the next, and to induce cooperativity. Cooperativity is going to be like when one molecule being attached to one of the catalytic sites influences the affinity of some other site for that for a like a specific molecule. I didn't even ask for all that, but just so I remember what cooperativity is. What is quaternary structure? It's like multiple tertiary structures bound together using like disulfide bonds, as well as non-covalent interactions. Honestly, okay, two or more separate polypeptides. Two or more separate polypeptides. Okay. What is a polypeptide? Let's just get the answer. Any chain of amino acids is longer than 20 amino acids. What is a fibrous protein? A protein that resembles long sheets or strands. That makes sense. What is a globular protein? A protein that resembles like spheres, spherical and round. What is a primary structure and what is its characteristic bond? Characteristic bond would be a peptide bond, no? That's like, this literally just the list of amino acids. Yeah, that's what I thought. Wait, hold up, I didn't read the top part. Yep, that's what I thought. What is a tertiary structure and what is its characteristic bond? We have hydrogen bonds between the side, between the side chains, salt bridges between negative and positive side chains, and what is it like? It's not non-covalent interactions. It's did I say that sulfide bonds already? No, I didn't. That's the last one. Nice. What is an oligopeptide? Okay, I low-key want to give myself hard on that one just because I got it wrong. What is an oligopeptide? It is a chain of up to 20 amino acids. What are tryptophan structure? Okay, so tryptophan is gonna be like boom, boom, but boom, 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 boom. Okay, so then we're gonna have this right here, and then the N is gonna go down there. Obviously, this is gonna be an H. I know this H is here, and obviously this is aromatic. Wow. I didn't check the W, but I think I'll be fine. Low pH ionizable groups tend to be protonated. At high pH, they tend to be deprotonated. It's like, those are repeated, right? Those are definitely repeated. What is an amino acid? amino acid. Uh, I don't know, bro. It contains an amino. Bro, are you serious? That is not the way you asked that question. I've, Hold on, let me edit it. So, why is it called an amino acid? Is more of the question. That is like I literally was thinking about this, but it's like super easy, bro. I got it wrong, but I would have gotten it right if the question was phrased correctly. What are glutamine structure, character, three-letter abbreviation, and one-letter abbreviation? Glutamine is, and then this is gonna be an amide. It's gonna be GLN and Q. Oh, wait, not Q. GLN Q, and it's gonna be polar. Glycine, it just has like an H. There's not even like. What are the two main structural classes of proteins? Well, I think we kind of went through it. It was globular and fibrous now. What is a nucleoprotein? I'm assuming it's a protein with a nucleotide prosthetic group. Is that what it's about to tell me? Yep. Nucleotide-based prosthetic group. What is a cystine? It is a protein. It is used to refer to the disulfide bond within a protein. Amino acids with acidic side. Okay, I don't like. I can't give myself that. Amino acids with acidic side chains they have low PIs. Why is this here twice? What would the titration curve of an amino acid look like? It's going to be a combination of 2 or 3 monoprotic titration curves. What is a subunit? It's one of the functional tertiary peptides in one overall quaternary peptide. What is leucine structure? Boom, boom, and then valine. It's gonna be Lu and L. It's nonpolar. What is a conjugated protein? It is a protein with a prosthetic group. Is that just what it is? That derives part of its function from the presence of a prosthetic group. In what direction are they drawn from end to C terminus? What is a residue? It's one of the individual amino acids in a peptide. What is a prosthetic group? What are some examples? So prosthetic group is a molecule that's covalently attached to a molecule that is covalently attached to a molecule that is covalently attached to a protein in order to assist in some way to its function. Its examples is like organic molecules like vitamins or like iron. protein with a carbohydrate-based prosthetic group. It's a protein that is spherical and round in shape. Quaternary structure. It is a combination of multiple polypeptides, like tertiary polypeptides of two or more separate polypeptides in tertiary structure. Okay, two or more. They resemble like rods, long sheets or strands. Okay. What is a polypeptide? A polypeptide consists of 20 or more amino acid residues. What is a beta pleated sheet? It is when multiple polypeptides, no, when peptide chains lie next to one another forming rows. It's a protein with nucleotide-based prosthetic group. Prosthetic group is a molecule that's covalently attached and allows the protein to function like an organic molecule like vitamins or metals like iron. There's fibrous protein. It's like proteins that resemble like long sheets, or I don't know, bro. It's like a rod, bro. Sheets or strands. Is it? But a protein, it is a strand, no? I don't understand, bro. Long sheets or strands. Okay, cool. Conjugated protein is a protein that derives part of its function from its prosthetic group. What is tertiary structure and what is its characteristic bond? Tertiary structure is the 3D shape. It consists of the hydrogen bonds between the side chains, salt bridges between the positively and negatively charged side chains, and the disulfide bonds. What is quaternary structure? It's the combination of two or more polypeptides in tertiary structure. With cystine, cystine is used to refer to the disulfide bond within a protein or in a protein. What is a fibrous protein? It's a protein that resembles long sheets and strands. In what direction from N to C? What will the titration curve look like? A combination of 2 or 3 monoprotic titration curves. I don't know how they're using the word in the definition, but it's alright, I guess. Alright, so 12:10 now. We finished 20 cards so far. We technically have 31 left. But we're just gonna do a little bit of editing over here. We're just gonna save that. We're gonna edit this. We just did 19, so we can put it up. We're gonna do an additional 50 in Pancal. I really don't want to do a biological mechanism right now. So we're gonna try to skip that as best as we can. Literally as best as we can, because I'm not trying to Okay, I think we can. I think we can honestly do this. We can do this one today. We can do this one today. All right. Visual. I kind of just read this when I was clicking on when I clicked on browse, but okay. Yesterday, I realized you guys couldn't see why I said don't bully me. It's because on my screen it shows up in like two different places that my DualShock controller connected. Um, but okay, so visual cues allow us to perceptually organize. So we'll click again, but I'm probably gonna remember that. Visual cues include, uh, I think one of them is like constancy, depth, maybe motion. Uh, I think that's all I remember. Constancy, depth, motion. I forgot about form. Okay. Visual cues that are. This is by visual cues that are by. It starts with a by by binocular cues. Okay. Binocular cues. They give you a sense of depth. Okay. Blank gives humans an idea of depth based on how much the eyeballs are turned. Um, Humans an idea of depth based on how much. I don't know. Oh, convergence. Um, Visual cues and monocular cues. The um, hold up. I'm like, okay. I won't keep speeding through this, but I kind of want to change the background. I feel like like I really wanna. I want to have something like space or something. Yeah, like this. Maybe like that. That might be that might be better considering that there's like a bunch of neon. I don't know if I did that at some point, but let's see. Visual cues that involve only one eyeball. I don't know if this is better, if I'm being honest with you. Let's see. Visual cues are they're monocular cues. But I feel like that's kind of hard to see still. That's like still hard to see. Like what background can I even put? Um, let's see. I'm getting so distracted right now, but it's okay. We low key zoom through our reviews. We're doing pretty well. Um, I feel like I don't want to do like something super crazy. I'm not trying to do anything crazy. I just don't. I don't want to have something like. Okay, what about this one? Is this one jokes? Hold on. Yo, low key, that one works fine. Hold up. That one actually works. Visual cues allow us to perceptually organize. Um, Visual cues include depth, form, constancy, motion. Visual cues that are a result of humans are called binocular cues. I'm probably not gonna remember. I'm probably not gonna forget that one. Blank gives humans an idea of depth, convergence. Visual cues that involve only one eyeball are called monocular cues. Monocular cues include. Okay, some of these are the same. Um, this is Okay, so we have size. I know size is one. Size, height, I think. Size, size, height, motion, parallax, shading and contour, uh, color. It's like, I think color is one of them. There's six of them. Okay, I I was wrong. So motion, parallax, and okay. So I got size, height, shading and contour. Um, I think did I say contour? I don't know. I didn't say constancy, even though I said one of them is the same. Um, interposition. Okay, I don't remember what any of these mean. Blank is a monocular cue where closer objects are perceived as being bigger. Monocular cue where closer objects are perceived as being bigger. Um, it's is obviously relative size. It's like context clues. Monocular cue where objects are perceived as being closer, relative height. Oh damn. I should have finished the definition. That's why I got that wrong. Blank is a monocular cue where object is perceived as being further away. This one is relative height, no? Is a monocular cue that uses light. Okay, this is literally like shading and contour. Like I can. Okay, it does say contour literally in the definition, which I don't like, but monocular cue. Oh wait, I accidentally clicked the wrong button. Monocular cues include. It thinks I'm gonna finish at 1:13. Okay, I think I'm gonna take an hour on this. We'll see. Monocular cues include. Uh, They include relative size, interposition, relative height, motion parallax, shading contour, and constancy. Blank is a monocular cue. Okay, I low-key did do that well. Is a monocular cue that can give a sense of depth through motion. Uh, this is motion parallax. Things that are farther away move slower. Things closer to you move faster. Is a monocular cue where objects are being perceived as being closer when they are in front of something. Where objects are perceived as being closer when they're in front of something. Oh, it's interposition. That states our perception of an object doesn't change even if the image is called constancy. States that our senses are adaptable and then they can change. It's Is this gonna be habituation? Sensory adaptation. That involves contracting our inner to dampen. This is desensitization. Bro, it's the same shit. In downregulation of sight, when it is bright outside, our pupils they're gonna constrict and they become desensitized. In upregulation, obviously they're gonna dilate and begin to synthesize I don't want to. I know. I feel like it has something to do with photoreceptor, light sensitive molecules. Okay, cool. What is a sense? Proprioception is a threshold at which you're able to notice a change in sensation. That's like, damn. I don't remember what this is called. Just noticeable difference. The J and D. Okay. Just just noticeable difference. Our senses are adaptable. Sensory adaptation. Wells contract hearing adaptation. Weber's law states that just noticeable difference divided by the initial intensity is constant. Perceptually organized. They include depth, form, motion, constancy. And upregulation of sight. Our pupils dilate and begin to synthesize light-sensitive molecules. The blank is the threshold at which the just noticeable difference is the minimum intensity of stimulus needed to detect a particular stimulus 50% of the time. I think it's over to R. The absolute threshold of sensation. Okay, I have no clue for these. The absolute threshold of sensation can. Why is it giving me so many cards to review? It's just gonna go. Are we just gonna go through the entirety of the new cards? The absolute threshold of sensation can be influenced by the following. Absolute threshold. Experience. Okay, I actually kind of know this. Experience, expectations, motivation, and awareness. Expectations, experience, motivation, awareness. So, like, okay, if you're expecting a text, how familiar you are with the text sound, whether you're motivated, and whether you're alert. Okay. Weber's law states that the just noticeable difference divided by the initial intensity is always constant. Closer objects are perceived as being bigger. Interposition. Damn. Okay. Sorry. That was kind of poetic a little bit, but it blank is the minimum intensity of stimulus needed to detect a particular stimulus. The absolute threshold of sensation is the stimuli below the absolute threshold of sensation. Subliminal stimuli. I didn't know what they wanted me to say for that. Somatosensation of. Okay, are these gonna be the list? Uh, this is. Is this? I think this is like thermoception. No, nice. Uh, Somatos. This is mechanoception. Nice. It's a monocular cue that uses. There should be like a nice counter or something. If I had a nice counter going, is a monocular cue that uses light and shadow, shading and contour. By experience, expectation, motivation, and awareness. Oh damn, awareness. I think it's the same thing, I'm gonna be honest with you. Binocular cues give humans a sense of depth. Binocular cue where closer objects are perceived as being bigger. Relative size. Nociception. Proprioception. Blank neurons fire at a constant rate. Non-adapting. Fire at the beginning of a stimulus and my fault. I didn't mean to do that. Is a stimuli below the absolute threshold of sensation subliminal? Fire at the beginning of a stimulus and calm down after a while. That's a fast adapting. Oh damn. It should definitely be fast. Why do they name these weird things? Slow adapting neurons fire at the beginning of a stimulus and calm down after a while. Slow adapting neurons fire at the beginning of a stimulus. Well, I guess that's true. I guess it's slow. That makes sense. Fire as soon as the stimulus starts, then stops firing, then starts again when it stops. I think that's low key fast. That's definitely the fast adapting one. I guess it's also the only one left, but uh, provides a sense of balance and spatial orientation. What system? The vestibular system are filled with endolymph, which uh is this the I think are these the semicircular canals? It's either that or the cochlea. Yeah. Okay. Fire at the beginning, slow adapting. The autolytic organs include the utricle and is it like the saccule? Oh my god. I don't know how I didn't think I would remember that. Um okay. We can give ourselves hard for that. Gives human an idea of depth, convergence, monocular, binocular, helped autolytic organs help detect it's like motion and direction. Oh damn. Linear acceleration and head positioning. I didn't get that at all. That was always hard. That was always a hard one for me. Is a monocular cue where an object is.
Check out my
Bro,
new music video, Deep End, on the Foundry play.
sorry guys. Um, where an object is perceived as okay. Let me. I feel like they just be cycling through these songs. Um, okay, so is a monocular cue where an object is perceived as being when its higher relative height. Just noticeable difference. The semicircular canals. Autolytic organs contain it's the hairs. They're like hair cells. Um they contain calcium carbonate crystals which attach to the the hair cells. And the hair cells have a specific name, which I'm sure they're gonna show up. I'm sure it's gonna show up in like 3 seconds. But I hope you got that right. All right. Help detect linear acceleration and head positioning, autolytic organs. Yeah. No. Damn it. Okay. Okay. Linear acceleration and head positioning. Yeah. States that the just noticeable difference is just noticeable difference divided by the initial intensity is constant. These include relative size, interposition, relative height, motion parallax, shading and contour, and constancy. Blank is a monocular cue where objects are perceived as being closer when they are in front of something, interposition. Autolytic organs contribute to the phenomena of dizziness and vertigo. Blank looks at how humans make decisions under conditions of certainty, of uncertainty. Are these Gestalt's principles? Oh damn. Signal detection theory. I guess they give a sense of motion of depth through motion. States things farther away move slower and things closer to you move faster. This is motion parallax. Minimum intensity needed to detect a particular stimulus. Absolute threshold of sensation. Unimportant stimuli can also be called noise. LMAO. It is the sense of position or proprioception of visual cues. Motion parallax is a monocular cue. It states that farther away move. Uh, things further away move slower. Things closer to you move faster. The monocular cue that states our perception of an object doesn't change, even if its constancy. Here it involves. Um, this is like the constriction of the ear canals to dampen vibrations and protect the tympanic membrane. In downregulation of sight, when it is bright outside, our pupils are going to constrict and they're going to become sensitive. Oh, wait. Oh, desensitized. Sorry. Looks at how humans make decisions under. This is signal detection theory, but I only know that because we just did it 3 seconds ago. It can be called noise. Oh wait, sorry. Our pupils' upregulation of sight, they're gonna dilate and begin to synthesize light-sensitive molecules. States that our senses are adaptable and that they can change. Sensory adaptation, hearing adaptation, sense of position in space. Just notice what is threshold at which you're able to notice a difference. Okay. I'm gonna give myself hard there because I thought since the word sensation, but I just didn't say it out loud. The absolute threshold of sensation is the threshold or like the point at which you're able to detect a particular stimulus 50% of the time. I low-key want that phrasing. So when it is bright outside, our pupils when it's bright outside, they're gonna constrict and our rods and cones become desensitized to light. Slow adapting fire, they're gonna fire at the beginning of the stimulus and then they're gonna calm down after a while. It fires at the beginning, then stops, and then starts again when the stimulus stops. It provides a sense of balance and I don't know, spatial orientation. Okay. Autolytic, utricle, and saccule allow us to perceptually organize, are filled with endolymph. Autolytic organs. Visual cues include depth, form, motion, constancy. Is the minimum intensity at which you're able to detect the stimulus at least 50% of the time. Its signal detection theory looks at how humans make decisions under conditions of uncertainty. Thermoception contain calcium carbonate crystals which attach to hair cells, provides a sense of balance and spatial orientation. The semicircular canals is a monocular cue where closer objects are perceived as being bigger relative size. Autolytic organs help detect linear acceleration and head positioning. Mechanoception is the stimuli below the absolute threshold of sensation. Subliminal is a monocular cue that uses shading and contour. Nociception, fast adapting. proprioception, expectation, experience, motivation, and alertness. Non-adapting, signal detection theory involves the constriction of the inner ear muscle to dampen vibrations and protect the tympanic membrane. Provides a sense of balance and spatial orientation. Vestibular system is a threshold at which you're able to detect the difference in what's it called? Is the just noticeable difference is the noticeable difference is a threshold at which you're able to detect a change in sensation. Same thing. Slow adapting states that the JND divided by the initial intensity is constant. JND contribute to the phenomenon of dizziness and vertigo. Provides a sense of balance and spatial orientation. Visual cues. Further away move slower, faster they move faster. It is a sense of the body's position in space. Noise. Absolute threshold of sensation. When it's bright outside, our pupils constrict and become desensitized. Uncertainty. The minimum intensity needed to detect the stimulus 50% of the time. Fast adapting neuron fires. Fires at the beginning of a stimulus, then stops, and then starts again at the end. Include the utricle and the saccule, autolytic organs. Fire at the beginning, then calm down after a while. Contain calcium carbonate crystals that attach to hair cells. So the endolymph, the signal detection theory, help detect linear acceleration and head positioning. Semicircular canals involves the constriction of the inner ear canals for dampening vibrations and protecting the tympanic membrane. The sense of balance and spatial orientation, at which you're able to notice a change in sensation. And very nice. Okay, well, that was our little session. I think yesterday we did 50 cards. Today we did, I think, like 68 or 69. I think we should be on pace. I think we're definitely on pace to finish. I think from now on, I'll probably be trying to. I need to probably watch some videos that I don't know if I can watch on here during the stream. If I can, I will, but if not, I'm probably just gonna do watch Yusuf Hassan's videos on some of the chapters, just so I'm not coming in completely blind, and I have some level of familiarity. Maybe I'll do that right before the stream. Maybe I'll do that like after, not after. Maybe I'll do that sometime before the stream. I don't know how far before the stream. Hopefully immediately before, but I don't know. But yeah, I think today was a fairly quick stream. This was maybe like an hour and a half or something. Yeah, literally like an hour 25. I think it's not too bad. In the future, I do want to do Uworld questions, but I don't think we're gonna be doing that today quite yet. Um, I think we need to implement doing cars more. Uh, so it should be cars. Then we can do these flashcards, and um, then do like Uworld. And I think that should be like a consistent routine in the future. Um, Hopefully, not all of my streams are gonna be this late at night, but yeah, I mean that's gonna be all for today's stream, and thank you to anyone watching.